everyone, we're looking at question number 3 of 2018 paper 41970 The question reads, a U-tube contains liquid as shown in figure 3.1. This is the liquid and the U-tube. The total length of the column of liquid in the tube is L. The column of liquid is displaced so that the change in height of the liquid in each arm is x. Okay, the liquid in U-tube then oscillates. So this is a simple harmonic motion question such that the acceleration a of the column is given by the expression this, where g is the acceleration of free fall. Calculate the period t of the oscillation of the liquid column for a column length L of 19 centimeter. Now, one thing I always tell my students is, every single time you get a question for simple harmonic motion, there are certain formulas, certain equations that should pop up in your mind at that very instant. The three main equations that are used in almost every simple harmonic question that I've done, that is, number one, x is equals to x naught sine omega t. Number two, it's v is equals to omega x naught cos omega t. And number three, we have acceleration as minus omega square x naught sine omega t. I hope we know x naught means the initial value, initial height that can be taken as amplitude, and then we have sine omega t, cos omega t, and everything. So what I do is, now if I look at this formula and then I look at one of these formula, I know it's matching with this one. So what they do is they use these equations and they just change these values to make it a little tricky, but what we have to do is, this x is x naught right here. Sine omega t isn't needed, so we can cut this out. We're left with a is equals to minus omega square x naught. Usually this is the formula we use. And then you have minus right here, and so obviously the only thing left here is omega square, and that is 2g over L. So I can say that omega square is equals to 2g over L. And since they want us to find the period t of oscillation, we know omega square, omega is 2 pi over t, so you have 2 pi over t whole square equals 2 into 9.81, because you always use 9.81. Make sure you do not use 10 for physics. 9.81 over L, which they've given us as 19 centimeter, but we have to convert it into meter, so it will be 0.19. Now it's simple maths. You have to make t as your subject. You solve this and you'll get omega square. You can take the square root and then make t the subject. So if we do that, we get omega as 10.2, and since omega is 2 pi by t, 2 pi over 10.2 2 pi over 10.2 is equals to capital T, and that gives you 0.61599, which you can write as 0.62. So your answer is 0.6. Moving on towards the B part. The variation with time t of the displacement x is shown in figure 3.3. They have given us a graph, and you can see from the graph that it's damping. Damping's occurring because initially the amplitude, the x was 2, and then it gradually decreased. The period of oscillation is of mass 18 gram is t. The oscillations are damped. Suggest one cause of the damping. Damping is obviously there has been a decrease in the amplitude, which means there has been some frictional force. So you can write, and if you just write frictional force, that would be too vague of an answer because you're dealing with liquid here. So you can write friction within the liquid, or you can talk about viscosity or drag, friction, anything, but you just have to be specific according to what the question has to say. So you can write due to viscosity of liquid. Viscosity of liquid. Then we have the second part, calculate the loss in total, is the keyword here, energy of the oscillation during the first 2.5 periods of the oscillations. Again, when it comes to energy, there are three main equations and formulas that you should know. One thing that's very important is, here I said that V is equals to omega x naught cos omega t. However, there is another, this is side information, but I believe this will prove to be very helpful in solving questions. V can also be plus minus omega under root, you have to put an under root, x naught square minus x square, and this is raised to the power 0.5, which is again under root. So in simple words, this looks quite complicated when I write it down, but in simple words, it's V is equals to plus minus omega x naught square under root x naught square minus x square, and you usually use this when time isn't given. Now we will use this V to write three more formulas that are extremely important when it comes to finding energies. Number one is for kinetic energy. We know kinetic energy is 1 by 2 m v square. Now I know what V is, so I'll say 1 by 2 into m into V square, which I'll say omega square. I'll just square all of this. So omega square x naught square minus x square. So all I did was I took this equation, I squared it, I got omega square, the square root got cut out, so I was left with x naught square minus x square. I hope this isn't confusing because it's all so messy. This is for kinetic energy, and we have one for total energy and we have another for the gravitational potential energy as well. So for the total energy, which I'll indicate as TE, that is 1 by 2 m omega square, 1 by 2 m omega square into x naught square. So you took this formula, you removed minus x square, and you just left with 1 by 2 m omega square x naught square. So if you learn kinetic energy formula, it will be very helpful. You can easily learn the total energy as well. And now lastly, we're left with gravitational potential energy, and since you used x naught square, you will be using 1 by 2 into m omega square into x square. So essentially what you did, you broke down this formula 1 by 2 m omega square x naught square for total energy and 1 by 2 m omega square x square for the gravitational potential energy. Now they have talked about the total energy, so we will definitely be using this formula. And they have said the loss in total energy, which means the final minus initial. So what we will be doing is going back and let's say for the first 2.5 periods, let's find 2.5. 2.5 periods is right here. Initially I can see that x was 2. This is x naught because x naught is amplitude, right? So initially it was 2 centimeter, and then at 2.5 it decreased to 0.95 centimeter. So what I'll do is one by 2 into m, which is 18 gram, and I'll write 18 into 10 raised to minus 3, which is 0.018. 0.018 m into omega square, which we found above, that was around 103. Once you found omega, you can just square it. 103, and then you have omega square, and then you have x naught square. So x naught square, you can say it's final minus initial, right? So final was 0.95 square. You can either find them separately or you can do the way I am doing. It's 0.95 square minus wait 103 into 0.95 centimeters, so it should be 0.95 into 10 raised to minus 2, which you can write as 0.0095. 0.0095 square minus initial was 2 centimeter, which is 0.02 whole square, and you just calculate this and you'll get the energy loss, which is 2.9 into 10 raised to the power minus 2.9 into 10 raised to the power minus 4. And this is it for your question number 3.